All right, for this problem, we have a little application of polynomials here. It says find the dimensions of the box. Sorry, that should say if the volume is 40 inches cubed. Find the dimensions of the box if the volume is 40 inches cubed. So if you remember from geometry, volume equals the length times the width times the height. So if you kind of think of this as maybe the length, the width, and the height of the box, we really just need to multiply them all three together. And we know that the volume is 40. So if we plug in a 440 for volume, V is 40, they tell us that up here. And the length and the width times the height, if we multiply all those together, it doesn't really matter what order. I'll do 2x times x minus 1 times x minus 4. And in order to solve this, we need to get the polynomial set equal to 0. Right now it's set equal to 40. So we need to get rid of the factors on the right side. We need to multiply those together, combine the 40 over, and then solve it from there. So it's kind of a roundabout problem, but let's go ahead and multiply this side out. So if I distribute the 2x through there, we'd get 2x squared minus 2x. And then that will need to be multiplied times x minus 4. So if we FOIL out the right side here, we get 2x cubed minus 8x squared. And then distribute the middle two terms here, we'd get minus 2x squared plus 8x. This whole thing equals 40. And we can combine our like terms here, so we get 2x cubed. And then if we add these in negative 8x squared minus 2x squared, that would be negative 10x squared plus 8x. And I'm going to go ahead and subtract this 40 over to the right side. So now that we're equal to 0. And if at any point you need to stop the video here and pause to get caught up or review something, then you can do that. Just resume whenever you're ready. So we FOILed out the right side. We got the 40 subtracted to the right. Now you can see we have a cubic polynomial. And the way that we learn to solve a cubic polynomial is by factoring by grouping when there are 4 terms. So I'm going to split this in half here. And the first half here has a GCF of 2x squared. And then if I factor out a 2x squared, that would leave behind x minus 5. And then if I factor out the second half here, 8 and 40, both of those divide by 8, which leaves behind x minus 5 as well. Now the way that we solve, or the way that we complete our factoring by grouping is that factor that matches, we factor that out front. We get x minus 5. And then the other factor is 2x squared plus 8. Now the way that we solve, once we've completed our factoring, and we're done now, we could factor this second one further. Notice that this quadratic here has a GCF of 2. So you could factor a 2 out front. And then that would leave behind x squared plus 4, which is a sum of squares. And then we have our x minus 5 factor. X squared plus 4, we know that factors as plus 2i and minus 2i. So our squares formula with our imaginary factors. And once this whole thing is factored out, the way we solve it is we just set each factor equal to 0. So just to review here, this here had a GCF of 2, so we brought the GCF out. X squared plus 4, that split apart into our sum of cubes, or sorry, the sum of squares. And then our final answer here, if we set each of these factors equal to 0, we get x equals negative 2i. That's one answer. We would get x equals positive 2i. That's our other answer. And then x equals positive 5. Now 2 technically is a factor. 2 times but there's no variable there. There's no x. So in other words, if I set 2 equal to 0, that doesn't really do me any good. There's no x to solve for. So you only get answers where there is an x. So you can see we got 3 answers here. 2 of them are imaginary. 1 of them is real. That is good because remember the number of answers that we get should always add up to the degree of the polynomial. So if the degree, the largest exponent was 3, we should get 3 answers. We do. We get our 2 imaginary ones. We get our 1 real one, which means this would only cross the x-axis 1 time at 5. Now we need to take this answer and answer the question that they asked. It says find the dimensions of the box. So obviously, the imaginary solutions don't really make any sense in the real world. So we did get those. We do know how to solve those algebraically. We've learned how to do imaginaries, but in the real world, that doesn't really make sense for the dimensions of a box. So 5 is our winner chicken dinner. So if you go up here and you plug in 5 for all of the x's, that gives us a length of 1 inch. 5 minus 1 would give us a width of 4 inches, and the height of the box 2 times 5 would give us 10 inches. And you can see if you multiplied those together, length times width times height, we would get 40 inches cubed. That is all.